As we gaze up at the night sky, a quiet wonder stirs in all of us. The stars we see are not just points of light, they are entire suns, many with planets orbiting them, just like our own solar system. These distant planets, known as exoplanets, hold endless mysteries. Some are gas giants like Jupiter, others are rocky and harsh like Mercury or Mars. But among these, a few rare ones may possess something far more profound: the possibility of life. For decades, astronomers have been searching for Earth-like worlds in distant solar systems, places where the conditions might be just right for life to exist. Thanks to recent advances in space technology, especially the James Webb Space Telescope, we are now peering deeper into the cosmos than ever before. And one particular planet, known as K2-12B, has caught the attention of scientists around the globe. K2-12B is located about 120 light-years away from Earth in the constellation Leo. It orbits a red dwarf star called K2-18 and is roughly 8.6 times the mass of Earth. It's classified as a sub-Neptune, which means it's larger than Earth but smaller than Neptune. When it was first discovered in 2015, scientists were intrigued by its location within the so-called habitable zone, the region around a star where temperatures could allow liquid water to exist on the surface of a planet. At first, there wasn't much that could be said beyond that. We didn't know what the planet's atmosphere was like or whether it had any signs of the ingredients needed for life. But then, in 2019, the Hubble Space Telescope detected water vapor in the planet's atmosphere. That was a huge breakthrough. It was the first time water had been detected in the atmosphere of an exoplanet located in a habitable zone. Still, Hubble's capabilities were limited, and scientists needed a more powerful tool to study the planet further. Enter the James Webb Space Telescope, JWST. Launched in December 2021, JWST has changed the game entirely. It's the most powerful space telescope ever built and is capable of analyzing the atmospheres of distant planets in detail, something never before possible. In 2023, JWST was directed toward K2-18b, and the results of that observation have sparked intense excitement and debate in the scientific community. Using its infrared instruments, JWST analyzed the light coming from K2-18b's star as it passed through the planet's atmosphere. This method, called transmission spectroscopy, allows scientists to identify the chemical composition of the atmosphere based on how light is absorbed. What they found shocked everyone. The telescope detected not only water vapor but also methane and carbon dioxide in K2-18b's atmosphere. This specific combination of gases is interesting because it could indicate the presence of a so-called Hycean world, a type of planet that scientists have only theorized until recently. A Hycean planet is a world with a hydrogen-rich atmosphere and an ocean-covered surface. If K2-18b is indeed a Hycean planet, it could be one of the most promising places in the known universe to search for alien life. What makes a Hycean planet so special? First, its surface is likely covered by vast oceans. These could be either on the surface or beneath a thick atmosphere. If temperatures are right, and models suggest they might be, those oceans could be stable and liquid. Second, the hydrogen-rich atmosphere would trap heat efficiently, possibly making it warm enough to support life even if it's far from its star. Now, here's where things get even more intriguing. The presence of methane and carbon dioxide, along with a lack of ammonia, suggests that some sort of biological processes could be at play. On Earth, methane is produced both naturally and biologically. It comes from things like volcanic activity, but also from living organisms. Detecting methane on another planet doesn't automatically mean there's life, but when combined with other gases like carbon dioxide and the absence of ammonia, it begins to form what scientists call a potential biosignature. A biosignature is a set of conditions or indicators that could suggest the presence of life. It's not direct proof, but it's a clue, one that points researchers in the right direction. And in the case of K2-18b, the clues are piling up. Some scientists are even suggesting that we might be on the brink of discovering the first signs of extraterrestrial biology. Of course, it's important to stay cautious. There are other explanations for these findings. Methane and carbon dioxide could be produced by non-biological processes, such as interactions between the planet's interior and its atmosphere. To truly confirm whether life exists on K2-18b, we'd need even more detailed measurements, or better yet, a way to directly sample the planet's atmosphere or surface, something that's not currently possible. But even so, the data from JWST marks a turning point. It shows that we can now study exoplanet atmospheres with remarkable precision. It proves that we're getting closer than ever to answering one of humanity's biggest questions. Just a few years ago, the idea of detecting potential biosignatures on a planet over 100 light-years away would have seemed like science fiction. Now, it's becoming science fact. Let's take a moment to consider what life on K2-18b, if it exists, might be like. With an atmosphere rich in hydrogen and the possibility of deep oceans, it's unlikely that life there would resemble anything we know on Earth. The pressure beneath the hydrogen atmosphere could be immense. The light from the red dwarf star would be dim and reddish, very different from our sun's yellowish glow. Organisms, if they exist, would need to adapt to these conditions. They might rely on chemical processes rather than sunlight to survive, similar to some of the strange lifeforms we've found in Earth's deep oceans near hydrothermal vents. On Earth, extremophiles, organisms that thrive in extreme conditions, have been found living in boiling hot springs, acidic lakes, and under high pressure deep below the ocean floor. These discoveries have shown us that life is far more adaptable than we ever imagined. If life can exist in such harsh environments here, why not on distant exoplanets with similar extremes? As research continues, scientists are planning follow-up observations of K2-18b using JWST and future space telescopes. They hope to refine their measurements, rule out false positives, and better understand the planet's temperature, climate, and atmospheric dynamics. The ultimate goal is to create a full picture of what this world is really like, and whether it might be inhabited. Beyond K2-18b, the success of JWST's analysis opens up a new chapter in the study of habitable exoplanets. There are thousands of known planets in the habitable zones of other stars. Many of these are awaiting further study, and with JWST and its successors, we now have the tools to study them in detail. This is a golden age of discovery. For the first time in history, humanity has the ability to detect the atmospheric fingerprints of distant worlds, to hunt for water, and to look for the subtle clues that might tell us we are not alone. It's an achievement that builds on centuries of exploration, from the first telescopes in Galileo's time to the high-tech observatories floating in space today. K2-18b might not be the only world like this. It may be one of many Hycean planets scattered throughout the galaxy. If that's the case, life may not be rare, it may be common. We just haven't been able to look in the right way until now. Imagine the implications of finding life on another planet. It would change how we see ourselves, our place in the universe, and even our understanding of biology. It would spark new questions. What is life like elsewhere? Can we communicate with it? Could we one day visit such a planet? While we are still far from definitive proof, K2-18b has given us a glimpse of what might be possible. It reminds us that the universe is vast, mysterious, and full of potential. As we continue to explore the cosmos, guided by powerful tools like the James Webb Space Telescope, the dream of finding life beyond Earth is no longer just a fantasy. It is a scientific pursuit, closer to reality than ever before.